Okay, so let's practice with algebra tiles. If I was multiplying an x plus 3 by an x plus 2. Right, we can do that. Did you want to try filling it in or do it together? Okay, let's do it together first. So we have an x times an x give you what? What would fit in this squared? An x squared. Look at those colors. Right. And x times a 1, what would fit in this next spot right to the right of it? 1 by x? It would be 3 x's. I'm using a crayon. 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 It's crayon, isn't it? Okay. What would go in the bottom right below it? Another x and another x. Okay. What does a 1 by a 1 create? A 1. How many 1s will we have here in this space? 6 1s. Good. So if we multiply x plus 3 times x plus 2, what's the result? We have an x squared. How many x's? 5 x's. Right? There's 3 here. And there's 2 here. Gives 5 x's. And how many 1s? 6 1s. Plus 6. Okay? So let's go down and try this one. C. Okay, what would be the expression of the 1 on the numerator? X what? Plus 3 or minus 3? X minus 3 times x. What's on the x minus 2? Good. Okay, so an x times an x, what does that make? An x squared. Okay, so would that be shaded in? Yes. Okay, now an x times a negative 1, what would that make? A negative x. So we don't have to shade it in. How many negative x's? 3. Do you see how we're multiplying? Okay, so we're looking for this spot right here, this x that I'm circling right now. We look right above it and beside it. So it's bordered by a negative 1 and a positive x. Do you see that? So when those two intersect, that's that tile right there. Okay, so the negative 1 intersects with the positive x, makes a negative x again. Do you see? Okay, a negative 1 times a positive x makes a negative x. Negative x, negative x, negative x. What would be right here? A negative x, because you have a positive x times a negative 1 intersecting at that spot. You see that? Okay. So again, below it, we'd have another negative x. It's getting messy now. Okay, what about negative 1 times a negative 1? What's that going to make? Yay! Positive. So those are shaded. Shade for the positive. 2 negatives. And since we have 3 and 2, it's going to make 6 positive 1s. So what's our solution? We have 1x squared minus 5x's and plus 6. Okay, so that's multiplying with algebra tiles. I don't particularly love it. It could show up on the curriculum, like on your test. So let's talk about using a grid. So the algebra tiles are a pain to draw. I don't know if you agree with that. So we can use a grid. So the last example, when we did x plus 3 and x plus 2, we can actually use a grid to multiply. X times x gives you the x squared. 3 times x gives you the 3x. X times 2 is 2x. And then 3 times 2 is 6. And our last step is we add, the diagonals is where usually the like terms are. So if I try to multiply this with a grid, I can write 5x minus 6 on one side, and then we have 2x plus 1 on the other. So what we're going to do is fill in the 4 boxes. 5x times 2x is what? So 5x times 2x is 10x squared. Negative 6 times 2x, negative 12x. 5x times 1, 5x, and then negative 6 times 1, negative 6. And so adding the like terms, which are often on the diagonal, we're left with 10x squared, negative 12 plus 5, negative 7x minus 6. Easy? No? Okay, so like to get this 10x squared, right, we're multiplying the 5x and the 2x. To get the negative 12x, then we're multiplying the negative 6 and the 2. What are its dimensions? Okay, let's try another one. See, could you draw algebra tiles with B? No, we couldn't actually draw that. We couldn't have it for multiplication. So this is where the multiplication using a grid is a lot better. Now we are going to learn an algebraic method today. But until then, we're just going to go through a couple different methods. The first method is algebra tiles. The second is grid. And then third we're going to do is algebraic. Okay? A squared times a squared. A4. Good. We add the exponents. Negative 5 times a squared. Negative 5a squared. And now we have a squared times negative 8. Negative 8a squared. And then negative 8 times negative 5, positive 40. Good. Okay, so what's our final answer? A to the power 4. So we want to go highest degree to lowest degree. So the constant's next, or the a squared's next. Negative 13 a squared, and then we put the constant last. That's 40. Yay! Do you want to try C on by yourself? You try.
Yeah, sure.
Why not? Why not? You done? PQ and QP are the same thing. Oh. I didn't line mine up very nicely. Okay, did you get 3p squared plus 29pq plus 18q squared? Yay! PQ. There wouldn't be a PQ squared. There wouldn't be a... We keep the same variable, right, and just add the coefficients. Okay, let's talk about area diagrams. So multiplication, do you remember long multiplication?
No, never again.
Don't worry, we're not going to. So this area model that we're doing, we can actually do it with numbers as well. Okay, so if I was multiplying by 32 by 34, we can break that into 30 plus 2. Agreed? Okay, and then 34, you could break it into 30 plus 4. Agreed? So then 30 times 30 is 900. 30 times 2 is 60. 30 times 4 is 120. 4 times 2 is 8. And then we just add them all together. So it's another way to multiply. So if I wanted to multiply 43 times 51, how could I break it up?
40 and 80.
40 and 3. 50 and 1. Okay, let's use our heads, like not use a calculator. What's 40 times 50? 2,000, right? 5 times 4 is 20, and then the 2 zeros. 5 times, okay, so Marcus, we go 5 times 4, which is the 20, and then we add each zero into it. So there's 1 0 and 0. Okay, 50 times 3. 150. 40 times 1. 40, and 1 times 3. So if we add that all together, what does that equal? Come on.
2,190.
There you go. No, it's not. That's a lot easier than log division.
How do you do long division?
Or sorry, long multiplication. 4 times 2 is 8. 4 times 3 is 12. Add a 0. 3 times 2 is 6. 9. Add them together. Anyways. Okay. So, we're going to learn about FOIL today. Guys, so FOIL and the distributive property are actually the same thing. So you'll see later down on your sheet there's something called FOIL. And FOIL is just, we're skipping a step for distributive law. So how does it work? Well, let me explain. When we multiply a binomial times a binomial, it's equivalent to, if we have a plus b times c plus d, a times a c plus d, and then b times a c plus d. Think of it this way. If we had a plus b in a chart and c plus d in a chart, right? We are multiplying the a by c and the d, agreed? Yeah, there it is. There's a c and a d. We are multiplying the b by both the c and a d. Is that agreed? Yeah, bc and bd. So we can also algebraically write it as, like if this is x plus 3 times x plus 2, I'm going to multiply the first x by x plus 2, and then the 3 by x plus 2. Okay? That's the distributive law expanded for a binomial times a binomial. Because we take, so this a, we're going to multiply it by both of these. A has to distribute to both, A and the C and the D. And then we multiply B and multiply it by both of these. Okay? So how do I write out the distributive law for the first one? What we're writing is the first term in the first binomial times the second binomial. Okay? Then we write the second term plus 3 times the second binomial. We're going to check if this gives us the same thing as a chart. So what is x times x? X squared, so arrows. X times 2, 2x. 3 times x. And then 3 times 2, 6. And then last, we collect our like terms. They're often in the middle. X squared plus 5x's plus 6. Okay, if we did a chart, x plus 3, x plus 2, we get the same thing, x squared, 3x's, 2x's, and 6. Okay, do you see how this is the same thing as this? Yeah, okay, so how would I write B out with the distributive law? I would take A and multiply by 2a minus 1, and then I take negative 7 and multiply it by 2a minus 1. Okay, great. So now we use distributive law. Now we can use our arrows. Let's go. A times 2a. 2a squared minus a times negative 1. Minus 1a, or minus a. What's negative 7 times 2a? Negative 14a, negative 7 times negative 1, plus 7. Then we collect our like terms. 2a squared. What's the middle term going to be? 15a minus 15a plus 7. Do you get it? Do you want to try e on by yourself? Okay, try it. 5a cubed plus 6 is only circled. Okay, minus 1 times 5a cubed plus 6. So when you multiply, Marcus, what did you get when you got multiplied 9a squared times 5a cubed? Put it down, please.
45, 80.
Good. And then plus?
Plus
54. Then?
I got 55, 80.
Good. And then?
Minus 6.
Is there any like terms here? No. Okay, so what is FOIL? FOIL is basically one less step than the distributive law. Okay, so what are we doing when we do the distributive law? Remember, or the grid, A, B, C, D. Remember, it gives us A, C, we have an A, a CB here, AD, and BD, right? If we use the grid. So when we did distributive law, or A times B times C plus D, what we're really doing is we want to distribute the A into both C and D. We multiplied A by the C, and we also multiplied A by the D. Agreed? There it is, AC and AD. So we're going to use arrows, rainbows, or something. So we first go A, so the F stands for the first terms in the brackets. So the two first terms, A times the C. Okay? The A times the D is the same thing as the outside terms. They're both on the outside. You see that? Okay? No? A and D are on the outside. Okay? And they're on the outsides. Then we want to multiply B by C and then B times D. See how B is multiplied by C and then by D. Okay? So B and C, they're on the inside. And B and D, they are the two last terms. You don't have to use FOIL. Okay, I'm going to show you how to use FOIL. Now, the cool thing about FOIL is binomial man. Yes, that is a thing. Let me show you. Okay, so if you have A plus B, C plus D, okay, we have our first, A times the C, right? I don't want the actual arrow. Okay, then we also have to do the outsides, A times the D. Then we're going to have to do the insides, B times C. And then the last, B times D. It's binomial man. Yeah, really? He's so cute. No? Yeah, so cute. Okay. So when we FOIL, guys, what we're doing is we're skipping a step with distributive law. Okay, we're just going straight to the multiplying. X times X. So the first, X times X. X squared. Then we want to distribute the X into the second term. So X times 4. 4X. It's true. It's what you've been doing this whole time. 6 times X. So now we distribute the 6 into both. 6 times X plus 6X. And now the 6 times the 4. Plus, is it that hard? No. We'll go through a couple more. Oh. So X squared plus how many X's? 10 plus 24. So it's just like distributive law that you're used to before, except for with a binomial times a binomial, we do it twice. So we're going to distribute the y into both of those terms. Y times y squared. Y times 2 is 2y. Now what? Negative 7 into both. So negative 7 times y. Negative 7y. Negative 7 times 2. Negative 14. Collect like terms and we get y squared minus 5y minus 14. Please try C. No. Okay. 3x. Whoa, I got excited there. 3x. 3x times seriously? 3x times x is 3x squared. Then 3x times negative 5, negative 15x. 1 times x is 1x. And then 1 times negative 5 minus 5. So your final answer, 3x squared minus 14x minus 5. Yay? How do we do D? Don't be foiled by FOIL. You write it twice. Don't be foiled by FOIL. To be foiled, right, don't be tricked. Right? If someone foils you, they're tricking you. So whenever you see a square, this is very important, you must write it twice. We can't just bring in the square to both terms. There's going to be a middle term. Okay? Common error is a student will do this. Here's the mistake. I'll see this all the time. They'll square the first term. They'll write 36a squared plus 25b squared. Wrong. Okay, so 6a times 6a. 36a squared. What's 6a times negative 5b? Negative 30. And it's good to go alphabetical, because then your like terms stand out a lot easier. Negative 5b times 6a. Negative 30ab. And then negative 5b times negative 5b. Good. 2 negatives. Plus 25. B squared. Okay. Are you with me? Collecting like terms, what's the middle term going to be? No. It looks like it, but they're not opposite signs. Minus 60ab. There's your answer. Okay, do you see the difference? There is a middle term. We can't just square the first and last term. We have to FOIL it when it's a binomial times a binomial. Okay, all right. Are we done? I don't think so. Yes, we're done. Okay, so your assignment is, no, that's not right. Page, also write it on the board, 288, thank you. Numbers 1 to 5. Whoa, and 7, A, C, E for all. Yeah, so 1 to 5 and 7, A, C, E. Okay, and then 6, 8, and 9.